our project video. It is titled Skittles Statistics Project. Can we really taste the difference? It is by Julia Holman, Carolyn Rayhans, and Grace Lipinski.
So a big important part of our experiment was studying taste and how it relates to sight specifically, and a huge factor in this is actually memory. So I was able to look a little bit more into the memory side of our human experience of taste and gustation, and here is what I found. So I'm sharing the screen now, and I wanted to show you this diagram of the tongue. Here is the human tongue, and I don't know if you can kind of see the mouse. Here's the tongue, and one of the most important nerves is the glossopharyngeal nerve, which leads directly back to the brain. Here it is. This glossopharyngeal nerve is the part that leads back to the brain, specifically past the hippocampus, where memory is stored, and then it goes to the taste cortex, where specifically taste memories are stored. And so that is where we get the connection between taste memory and sight. When you look at a certain food or a certain color, then that triggers the memory inside your brain of what you think the food should taste like. And that's it.
These are the methods we used for our stats project. First, we had lined up a bunch of contestants to be, or participants in our project. We blindfolded them and then had them pick out one Skittle to eat. Once they ate their Skittle, we would ask them what color or flavor they thought they had. From there, we'd mark it on our spreadsheet if they got it right or wrong. So then we can collect that data and further look at it later. The variables we had were people ages 0 to 20 and then 20 plus. We also had male and female, so we can later look and see the differences between the older and the younger, and the males and the females. From there, we used a bar graph to show the difference, to show the different proportions between the younger and the older age groups, and also between male and female, because when we first looked at the younger and older, we saw that there wasn't much of a difference. We also used a bar graph, again, to show the null distribution. And these are just some of the methods we used for this stats project.
Alright, so this is the results part of our video. I've pulled up the applets that we used. So this is the one proportion applet. We did 3 simulations, one to test the proportions between male and female, and one to test the proportions between the 2 age groups, and then one to test the probability of people guessing the correct color in general. So this one is for male and female. Here's the bar graph that shows the proportions, and then the observed difference and the confidence interval. And over here is the graph. So this is the p-value, and this is the null distribution. There's the normal distribution. This one is for between the 2 age groups. So again, we have the proportion bar graph. The difference is 0 because the proportions were the same. Here's the confidence interval. And then again, we have the graph, the p-value, and the normal distribution over the null distribution. And here's we use the one proportion applet to test the proportion of people who would get it correct in general. So the success probability is 0.5. This was our sample size, and we did 1,000 tests. So this was the p-value down here, and here's the null distribution. We could put the normal distribution over top of it. And yeah, that's the results portion. So this is the reference part of the video. I am sharing the document that we have put the references on. So these are the articles and pages that we used in the paper and the video. So the first article is called Learn Color Taste Associations in a Repeated Brief Exposure Paradigm, Food Quality and Preference. The next one is Infant Sensitivity to Arbitrary Pairings of Color and Taste. And then the influence of color and label information on flavor perception. And then food memory discovery shows how we remember taste experiences. And that's it. So these all were articles that showed the history and the science behind our tongue and our taste buds, and then we use that to help us with our project.
So after doing the statistics and running a couple simulations and looking at all of the numbers and everything that was lining up, we concluded that the p-value we received from the simulation was significant, but it was not a huge difference. So it was enough to reject the null, which our null was that people cannot taste the difference between the different Skittle flavors, colors, and the alternative was that people can taste the difference. So we are rejecting the null and accepting the alternative that people do taste the difference. But we just have moderate evidence that age and gender affect taste, and only moderate evidence that people can truly taste the difference between various colors, whether they tasted the right color or the wrong color. It was up to just like how close they were to the actual color. So then on top of that, a way to improve this experiment was maybe if we had taken into account whether people like Skittles, or maybe if they don't like Skittles, then they wouldn't taste the difference very much. And also we tried to randomize our sample group, but sometimes that is hard, so I would not generalize it to a larger population. Those are our conclusions and discussions from this study.